I just pressed it. Yep.
Now we are live. So let's start. No, thank you. No, thank you. We don't focus on the questions. Hello everyone. We are having now here our Google Summer of Code panel session. We have this year the 20th Google Summer of Code, and for everyone here who is interested to participate, we have here several people experienced with Google Summer of Code, either as a contributor or as a mentor or as both, and tell about their experience. And we will also have a Q&A session. You can ask questions about Google Summer of Code, and we all will answer them.
Okay, just to break the ice, does anyone know what is the recent change that has been brought in Google Summer of Code maybe 2-3 years back? And anyone answer what is the biggest change that has been brought in? Yeah.
You don't need to be a student anymore.
Yeah, right. So you do not need to be a student anymore. You do not need to be enrolled. Earlier, there was a rule you have to be enrolled as a student in any university anywhere in the world. But that rule is no more there. So if you are new to open source, irrespective of the fact that whether you are a student or you are working somewhere, you can contribute for GSOC. But the thing is, if you're working somewhere, there shouldn't be any problem from your employer, because along with GSOC comes a stipend part, which majority of you are interested in, I'm sure. So there shouldn't be any problem with your employer. So if you're okay on that part, you can start contributing for GSOC. And as Tim mentioned, this year is the 20th year of Google Summer of Code, and the program is growing day by day. Does anyone know how this works? How are the organizations selected, or whether it's going to be say suppose you are contributing for organization X. So, will you be able to contribute to the same organization next year? Does anyone know how it works? Any idea? Any idea? Okay. Let me explain it. So, as of now, say suppose there are n number of open source organizations in the world, right? Even you can start your own open source project. By organizing, I guess you know what is the difference between an organization and a project. So organization has more governance involved in it, there's a structure, there's a body associated with that. I might start my own open source project, but there has to be a basic governance in place, right? Otherwise, you cannot call it an organization. So tomorrow, say suppose I have my own open source organization. There are a few people who are maintaining it. There is a governance, and I start applying for GSOC. Okay. So will I be accepted, or will I be able to put up my project? It's not basically of that sort. So typically around February every year, Google will be opening the slot So they will invite all the open source organizations to like submit their proposals or like to submit this request those submit their participation request or however you call it. So suppose that say there will be 100 organizations who will be submitting their request. So there is an organization team in Google who are dedicatedly checking these things, who will be checking the potential of the organization, what are the projects that are put up by the organization, what is it that they want to do, and these things. And it will be the decision of the Google team whom they want to select. Okay. So it is not like if there are 100 open source organizations who have applied for it, all 100 will be selected. It's not like that. Maybe out of that, they will select 40 or 45 or 50, whatever it is. And these are like just some numbers that I'm referring to. Then a particular organization is put up, okay, or they are selected. Now it is up to the organization, like they have to publish the projects that they want to have for the Google Summer of Code, and then they have to put it their page and to publish it. And after that comes the student application period. So the students get to see those kind of projects, those projects what are there, and they start applying for it. Okay. After that, it's say there are 10 projects, say open printing. Open printing has put up 10 projects. So it is not that we will be and like maybe 50 maybe say 15 students contributors. By the way, this term is no more there, the student term is no more there, it's all contributors that is said in these all. So the 15 contributors apply for those 10 projects. Okay. And then it's up to open printing whom they want to select. Maybe they have 10 projects, so they select the best 10 out of those 15. And then they mention it to Google, okay, these are the 10 students whom I want to go for, or these are the 10 projects which I want to go for. Okay, not students at that point of time, maybe these are the 10 projects that I want to go for. But it is absolutely up to Google like the slots. It might not be that Google gives like all 10 slots. It is based on the budget they have, based on the criticality of the project, but how they do it, that is absolutely up to them. So finally, they will inform the organization, okay, we can give you 8 slots or 6 slots or whatever is it. And then those 6 slots gets published. Now, say there is person A and person B. Both of them might have, person A might have submitted for project A and person B might have submitted for project B. Okay, but when the selection, when the list comes up, you might see that person B got selected instead of person A, irrespective of the fact that it was a brilliant proposal from like person A. Maybe person A had a brilliant proposal and person B was not up to that mark of person A, but while the selection list came out, it was person B who was selected. So you might be like disheartened to like okay why was I rejected or something. So it is also organizations also have, if they are not getting enough slots from Google, they get 2 slots, and if they did not get 2 slots, if they got like only 1 slot, at that point of time they need to select the most critical project. There might be two projects. Project B might be of more importance than project A. That's why they decided to like go with project B. I mean, the proposal from project A might be of might have been a better one. So these also happens in the background. So I hope I made it clear how this application process works out. And then once it kicks in, like there will be the community bonding period, then you work on the project, you complete it, and if you are not able to complete it, it's broken into phases, like it will be marked as failed. And if you complete it, I mean, you get a good stipend, and then you carry it forward. Okay. Does anyone want to add anything to it? you want to add on the project tenures and all, like long projects, short-term projects, the duration, hours?
Yes, we have also the choice when you want to apply as a contributor for a project. You can choose between a small, a medium, or a large project. A large project is something to be done in estimated 350 hours, which would be something like 12 weeks of full-time work. And you can choose a medium project, which is 170 hours or one half, and, or a small project, which is only 80 hours, one fourth, probably more or less. And so there's this flexibility for the definition of projects, and so there are more chances for differently sized projects and for contributor candidates which have different ambitions how much they want to do. And we also have one nice feature which was recently added. In the beginning there were 12 weeks, fixed 12 weeks in which the students were supposed to do their work, but or the contributors. But in reality, this is not always possible because the summer break on the colleges all over the world is not always in the same months, or during these 3 months, students, for example, could have exams and so on, or family emergency could appear. And so we have the possibility to move out the deadlines for midterm and final evaluations, so that by this way, a student can, a contributor can do their work later. It requires the org admin to do the change of the deadline, but the flexibility is there that a contributor could interrupt their work or could do all the work later and so on.
Yeah, and one more thing is like the student stipend is based on like from which country you apply from, and like it's decided on the cost of living on cost of living for that country. Earlier it used to be a flat one, but a couple of years back it has been changed. It's all decided by Google based on the cost of living of that particular country. Maybe somebody who is doing it from India might the stipend in India is quite different than that of US or Germany or some other place. So it all depends on the kind of like cost of living that is there in that particular country.
So now I think we should start that everyone here in the panel should introduce themselves and tell about how they got into the Google Summer Report. Let us start at that side. Yeah.
Hello and good afternoon, everyone. I am Ruth, and I am the research contributor for this year for the Organization Service Foundation. In my case, I got introduced to open printing from OSC 1 itself. There I saw Kavit sir and Prince sir giving some lectures on how I can start contributing to open source. Also, there are lots of seniors in my college who are doing research in the Linux Foundation itself. So I got mentored from them and I taken some ideas and started contributing to the organization in, I think, from December. So it is the number of contribution you are making in that organization matters a lot. Also, how you are going to approach your problem, how you are going to approach your project, it also matters. So that's all. You should write a good proposal.
Hello everyone. Yeah, so my name is Aryan and My name is Aryan, and I've been the GSOC contributor for the SET Foundation, SET Dashboard. I was a contributor in 2022, so it's been a while, but a lot of things have changed since then. Like Amin mentioned, that even professionals can contribute now, but my journey was that similar to his, that my college seniors informed me about this this is a good thing. But there was no one who contributed to the set foundation that I knew of. I just looked up at the organizations and projects that they had, and I really liked one of the projects. It was called Visual Regression Testing for the set dashboard. So it seemed like a new and revolutionary way of testing front-end applications. And I didn't have any open source experience before then, so it was a really good experience, and I had with Google Notebook you also get a mentor and everything, so it really helps you get a good environment to get groomed and get introduced to open source, and you also get access to the production level code and someone you can ask questions to, which is something that is very overwhelming if you don't have prior experience. So, yeah.
Hi everyone, my name is Shivam Jaiswal. I was also selected for Google Summer Code this year at Linux Foundation. And my journey was quite similar to Ruki. Actually, we both are from same college and we both visited to the first OSC session that was organized in IIT, and from that we started exploring this field that how we can get selected for Google Summer Code. Then we contacted some of seniors and we got to know their experience, how they work, how they got selected for Google Summer Code. And actually, I started a month or 2 months late from Google, and then when I contacted the admin administrator, and I got to know about some issues and that I could work on. I tried on some issues, and then I couldn't totally solve those issues. Still, I got to know about the project that was from under this year GSOC, and I was interested in one of the projects which was including Python and other stuff. So I contacted him and to ask him that I would like to work on that project, and then I submit my proposal and just got selected for the position. So this was my journey.
Hi, I'm Saman. I'm a mentor for this year's Google Summer of Code with the Linux Foundation. I started my career in 2017. I was a student in 2017 and 2018 for the Linux Foundation. And then after that, 2019 and 2020, I was a mentor. And then this year again, I'm a mentor. So I contacted the admins. I was going to this organization and I contacted the admins and said, okay, I can do these kind of projects. There are a couple of projects listed in 2017, and they said that okay, let's try it out, and that's how we kind of started. In the midway, we also changed projects because we realized that there was a higher priority project which had to be done, but yeah, that was going on. Another most important thing, so all of them spoke about like how they contributed like as a student. So two other, so GSOC comprises of, there are three primary members of GSOC. So one, of course, is the student who needs to work on any particular project or any particular idea or proposal. The remaining two most important people, like for any particular piece of project, is the mentor and the organizer. Okay. So the mentor needs to guide the student on a regular basis on how they should work on the project. So there, I mean, the success of a particular idea or project should depend upon the student as well as on the mentor, how well they are able to guide the particular student. And there is also another important important figure in this particular ecosystem, that's admin. Okay, So fortunately or unfortunately, myself at Till, we are the org admins for the Linux Foundation umbrella for GSOC. So, if you need to know anything or like I said, Linux Foundation resource projects, you can reach out to me at kasu.awik@gmail.com or p.computer@gmail.com. You'll get our links in the links and email IDs in the wiki page of like the Linux Foundation resource projects. So our role becomes primarily on the governing part. So like I'll explain that it's not only us, it's typically what any admin in any organization they are doing. So first thing is they are responsible for making sure that the right candidate is getting selected in the entire process, right? So whether the selection is happening properly or like whether because we also do not want to waste our time selecting by selecting a wrong candidate or like we do not want to give undue preference or any we do not want to be partial to anybody. So we try to make sure that the mentors are doing the right job in selecting the right candidate. And there is some additional responsibility for the organizing of any umbrella organization because umbrella organization is not about in a single project, right? There will be multiple projects under umbrella organization, and it's very critical that we need to suffice the need of all the organizations taking part under the umbrella organization. So it's absolutely the admin's discretion how many slots they want to allot to an organization under that umbrella. But at the same time, we need to be impartial. We need to see like we are doing due justice to all of the projects under that umbrella. Say suppose we get 10 proposed 10 slots for an umbrella organization, it shouldn't be that we give all the 10 slots to one particular sub-org and like we do not give anything to other. We should have, that is not at all acceptable. So we need to make a due justice to all the sub-orgs. So that is one of the critical parts that we need to handle from our side as org admins. The second part of it is, say suppose one of you gets selected for as a GSOC student to work on any project, right? It might always happen. You might not feel comfortable with your mentor, or if it is like you are reaching out to your mentor and your mentor is not helping out, your mentor is not providing the proper guidance, your mentor is not responding to your messages or emails, what do you do? Then it's time for you to reach out to the admins. It's the admin's job to make sure that things are happening. It's the admin's job to make sure that the mentor is responding. If the mentor is not responding, it should be the admin who should figure out who can mentor you, in place of your designated mentor. So that's where the role of an admin comes. So any problem while working on the project, you should reach out to your admin, your org admin for any kind of help. And the vice versa. If the student is not responding, if the student is not, coming up to the speed, the mentor can also reach out to the admins and ask for suggestions on what needs to be done. But one primary rule, once you get selected, make sure you are having a regular connect with your mentor. By regular connect, say like maybe twice a week, check out with your mentor on their suitable timings. Everybody might not be comfortable with everything. Few might be comfortable with chats, few might be comfortable with video calls, few might be comfortable with emails. To just check out with your mentors. And it's not like when the submission time comes up, you push in all the code all together. No, you should do it gradually because you need to give time to your mentor to check the code. Say suppose on the very last day you push in everything and then some error comes up and your mentor thinks, okay, this guy did not do anything and because the required output is not there, so he or she hasn't worked on it, I will mark him or her as failed. Right? So it should be an incremental thing. It shouldn't be like on the very last day you push everything. Okay.
Yeah, as we mentioned, I think the biggest part of GSOC is good communication with mentor and the whole organization that you're targeting. I think that's the key. Having continuous communication and showing progress in increments is the best way to have a successful experience.
Yeah, I do remember one scenario when there was a mentor was trying to reach out to the student, and the student has been saying that yeah, I'm working on the code, don't worry, I'll submit it, but it went on and like the 1 month period, the first first phase was almost over and the submission came in. So it was almost a submission time, and the student knew like to get the money, I need to submit the code. What he did is he submitted all the code on the very last day. And the mentor did not have enough time to check it out because of their schedules. And what the mentor thought is like, that guy marked the student as passed, okay? And the student happily got his first stipend. After that, after first phase, maybe after 1 week, when the mentor had got time, the mentor tried to see like how is the code building or whether it is working. And it was found out to be all junk code. So nothing works. It was not even building properly. So you can understand the scenario, right? It was not justified enough for the mentor to mark it and failed on the very last day because mentor was not sure. It might also be the fact that the code was a proper one and it was all working, but they had to you cannot mark it as fail as well, right? In case it works. Also, when he marked it as pass, the student got the stipend, and that was all he was aiming for. But it was all junk code which was submitted. So, for us, we have made sure that if the student is submitting the code on the very last day, we are not going to accept it. And there is a kind of an agreement which we make all the mentors sign while they are applying as a GSOC mentor that you have to come up uh, with your decision for a pass or a fail 48 hours prior to the actual deadline of Google. So that we make sure that the mentors do also check the course, do also check with the students on a regular basis. They should be knowing what the students are doing, right? So this is how it works in the Dynamic Foundation. And on the very last bit, we also do not want to chase a mentor or the student to check the status of stuff. Any questions? So everybody is either we are explaining it very nicely or everyone knows it.
For someone who is new to development,
For someone who is new to development, what advice would you give?
For someone who is new to development, what advice should we give for applying to GSOC or like in general?
in general,
Okay. So if you are new to development and if you are interested to applying or like working for open source, first thing is as I said in my talk in the first talk yesterday, learn out the basics. There are certain things which is common in any software project or any software application or company that you do, like the version controlling. The version controlling, if it's proprietary software, they maintain their own things, and if it is an open source, typically it will be in Git or like similar stuff. So you should understand how Git works. What are the basic protocols? What is the PR? What is the fork? Or what are the basic that works in open source stuff? Then how do I build? There are different projects with their own way. So learn this basics. Okay, you can easily get it from YouTube or there are multiple materials available in the YouTube. And then the next thing is figure out your area of interest. Right? So there are multiple things available in this world. So we have projects on astronomy, we have projects on yesterday I was showing an example. There is a project like open source malaria project. So you can also contribute for that. There's nothing wrong. This open source is not about software only, right? So you have to figure out what is your area of interest. You might be interested in hardware as well. So once you figure out your area of interest, once you learn the basics, the next phase is like check out the website, try out the communication channels that particular org is having, uh, join the community, and figure out the good first issue to work on. If you go to Git of that particular project, there will be some good first issue, which means the easy issues for any beginner to start with. So start with that and gradually increase the complexity. So it's a step-by-step process.
Yeah, I'd like to add that that's a common question I used to get when I did my GSOC in my university. A lot of people ask me, how do I get started into development? What I usually recommend is just try everything, at least in your initial years of college. Where there was a workshop on firmware development as well. So the limits are endless, and too many ways to access information. Just do what you like, and that's what I did in my GSOC. I really liked web development and found a project that seemed very interesting. I just looked it up and found that this is something I can do and made a proposal out of it. I think that's the best way. Just try everything in your initial years and stick to one thing and just try it out. Thank you so much.
I'll add to this. First of all, I am sure that a lot of you have a lot of questions. So if you have questions, just ask. There are no dumb questions. First of all, right? Even if there are things that okay, I should ask a question or not, just go ahead and we figure it out from there. The other thing is when you ask, how to get started. It's a lot happens, right? When you say that, how do I get started? And you get into a dilemma where you don't know how to get started, but you want to get started, but you don't know how to get started, but where to start, right? So this is very common for all of us. Even today, it's very common. If you tell me that okay, you have to do something, you have to build a house. I don't know where to start, right? So the first thing is asking questions, right? And I would suggest you to ask a lot of questions as much as possible. The other thing is I want to give you an example, right? To understand how to do things, anything, right? So let's say this chair is there in front of you, right? There's a chair there. How and you have a log of wood, right? How would you build the chair from that wood? Can anyone come up with a plan of how to start? And you have a log of wood and some paint. How would you do that? All the tools basically. How would you start? Building that chair out of raw materials. Anyone? Don't shy out.
We can just start with making the structure for the chair and trying to basically the painting comes at the last.
Okay, that's one way.
What do you mean by raw material? If you mean a block of wood, I would also have to sketch out dimensions and then find the hacksaw and then.
You have all the tools, just the tools, just the tools.
And by it's a raw material, right? By raw material, you mean what? You mean a block of wood?
Yeah, block of wood.
From IKEA or
Just a block of wood, just a big block of wood, infinite block of wood, and all the raw materials. How would you make a chair?
I would have to consult an engineer. I don't know how the calculations that go into making a chair stable, and how much load it can bear. So I would have to consult someone else about how that how to build a proper chair that can do that. Then once they have give me some guidance, I try to chop like chop cut what wood or whatever I have to do to be able to build a chair. Then I put the parts together. That's a little bit thing. What parts, what kind of screws are best for any, what kind of joints are best for any sort of material. So I guess that is a general process.
Yeah. Anyway, that's how would you build the chair. Right. We start with designing and then how much we have to cut, yeah, then start joining the pieces and paint it, right? Right. So anyone has anything different, how would you build a chair? Maybe go to Amazon and buy a chair directly, but build a chair.
We just start writing and after that we just might in the parts, and we take help from other sources like because we have all the raw materials and all the things.
Right. So, so this example I want to give you is basically how to build anything. When you're trying to build anything, even software, the first thing you need to do is come up with requirements that what are you trying to do, right? Just list it down and say that okay, I need to build a chair. It should have the first very detailed. The first is what is I need like block of wood, paint, right, nails, and a hammer, things like that. These are the tools I require. The next thing would be the first step one, shape the chair, come up with design. Second would be cut it into pieces, right? The third would be figure out where to put the nails, things like that. You come up with a plan, right? And then for each of the items in the plan, you implement that, right? The first thing would be you have a block, you cut the different pieces of the chair. You cut the different, the length of the chair, the back of the chair, things like that. Then coming to the next step, which would be nailing, where to nail exactly, right? So what you did here, because it was a very simple example, it was very intuitive. Like even with like a week of practice, you can build a chair. Maybe the first chair you break and sit on it, it will break. Maybe, right? But the thing is, you will be able to build a chair. And why you are able to do it exactly is the reason that you are able to break it down into small parts and you are able to do the entire task part by part. This entire process is called outline speed running. You can search it on Google, outline speed running, right? So you build an outline of the task and you started to go over the outline and you started to achieve that. Same goes with any task, including this one, right? Or any other even that like that will run a question that how do I even start with coding? Or I don't know coding at all, what to do? So you come up with a plan and see that okay, what is coding? I don't know what is coding. So the first question is what is coding? Then see what are the programming language, things like that. You come up with a plan and you try to answer and you try to fill as many questions as you can. So you build a mind map kind of things, right? So that is how any task, that's how I do any task itself, right? So, yeah, I think that was.
So we have now 4 o'clock and 5, and now for me, I will give a workshop now about Snap in the workshop room, which will start right now. And therefore, I have to leave. I don't know whether Abid will continue here, but he is probably also another talk. So it was, I hope you have liked it. I hope we have answered your questions well.
Have any questions, anyone?
So any questions or else we can wrap up?
Can you please tell me, to speak, someone say that you need to contribute in that companies with recreating so if I have a good interest in machine learning and someone says that it is very difficult to contribute in that field. So what I choose, any easy thing is what is easy or any interesting thing, but I have a good interest in this field. I want to contribute in this field.
I didn't understand the first part. So you said like it's whether to contribute for the organizations which are contributing regularly or which are participating regularly.
Which participating regularly?
No, you don't have to think in that way, like whether you want to contribute for any organization which are participating regularly. No, don't think about that. What I tried to explain in the process, the entire ecosystem, the entire process of end-to-end process, how it works, right? I mean, don't think in that way whether the org gets selected every time or not in that way. You do not think about it. Your point of interest is in the contribution, right? What you want to do, what is your area of interest. And while you are applying for GSOC, that particular organization has already been selected. That's when you have the project put up. But yes, this might always happen that you start the journey from somewhere and finally you see that all was not accepted in GSOC. That can very well happen. But the experience that you build, that will help you. Say suppose you are interested in something like Gen AI. Okay. So you are contributing for org A, and org A, that particular organization was not accepted for GSOC that particular year. There might be some other organization which might have been accepted for that they might be working on GenAI. So you can tell them that hey, I have worked or I have contributed in GenAI in this particular organization, so I would like to do it here as well. So all the experience that you grow up, or that experience that you develop, so that helps you out. So do not think in that org specific way. Just think what is your area of interest. So there might be multiple organizations who might work in the same areas. So, or it might be like, say, suppose you are contributing for open printing and open printing does not get selected. So maybe next year there will be, or you might get a chance in a different way, or you might use this experience in some other ways. So don't think it in that way. Thank you. There was one more question to that. Yeah. Any suggestions on building the proposal? So
Like what all should it have? Like only the idea and the text and then it used to build it.
while you are building a proposal, make sure that you are putting in enough details how you want to develop that, how you want to work on that. It shouldn't be like you put it on a very top level view. It shouldn't be like that. It should be with more details. So once you put in more details, the mentors or the selectors start this confidence, like okay, this guy has understood the details. So while preparing your proposal, if you need any help in understanding the project, get in touch with the vendors, ask them questions, get it clarified, and then create a proposal. So just do not go ahead and create a proposal based on what you have understood. Get it verified and get it checked with the vendors whether your understanding is correct or not. Then go ahead and create the proposal, right?
Some of you have specific templates you should follow. So you have to make sure you know that what the org expects and ask these questions.
Also, is it possible to apply for multiple launch projects or is it?
Yes, you can apply to multiple orgs, but don't apply to too many because everyone can see. There's a rule.
I think only you can submit 3 proposals in different organizations.
But there is a catch.
There is a catch. Say suppose you apply for two organizations or two proposals, and both of them get selected. Okay. So what happens then? So it is like the both the mentors or board candidates of both the projects are notified by Google if this particular guy has been selected, both the areas, and then the all candidates or the mentors discuss among themselves like one has to, it's like one has to accept and one has to work with it. So it's better if you can stick with one, otherwise like it becomes a tough job for the mentors and like admins. But yes, there are scenarios where there are people who get selected in multiple projects.
What actually happens is the following. The mentoring organizations, when they ask for their slots, they have to list the projects they want to accept in a ranking. For example, if they want to accept 10, they have to say this is first place, this is second place, and so on. And each organization does it this way. And when the student, when the contributor is accepted from more than one organization, the organization who has ranked highest gets the contributor. For example, if A puts the student on third place and B puts the student on fifth place, A gets them.
So I have some. Yeah, I have something on the question asked, like how should you come up with a proposal or any. So if you should look at proposal as a design document and it should be complete, right? And the example I'm giving right now is the same. I've written a lot of documents in work as well, and we have to write documents like almost every 2 weeks. Like, to do anything big which impacts anyone in a software company, you have to write a design document and it get buying, right? So think of it like this. First, come up with the introduction. Right? There are some sections which I usually use. if there is a format like the person here mentioned, that if there is a format which is followed by the organization, we follow that. Otherwise, the best way would be like the way I follow it, and you can make changes. You should first write down what is the introduction, like what is the that this is the introduction. The next is background. What was the history of the problem? Think of it like Wikipedia, right? Wikipedia also has a background context, right? So you should have the background so that anyone who is reading the document has all the context, right? The next thing comes is problem statement, right? This is my problem statement, and this is what I need to solve, right? Then you have requirements, right? Requirements are further broken down into two things, functional and non-functional requirements, right? So the functional requirements means how should your product or what you are building behave, and non-functional. Okay, okay.
Yes. Now I'm to really leave for my workshop. Anyone who is interested can go with me, and anyone else can continue here, ask questions, and get more knowledge about Google Summer Code.
So that's at requirements, right? So you break the requirements into functional requirements and non-functional requirements, right? Functional requirements means how something should function, right? We took an example of the chair, right? The chair should be able to sit one person and not break. The chair should not wobble. The chair should be stable and things like that. These are functional requirements. And then we have non-functional requirements. The chair should be beautiful. It should appeal my eyes. It should have brown color. Not that these are functional, but they are non-functional requirements. Similarly, for software application, they should not break. It should be robust, things like that. And non-functional would be it should be very fast, things like that. But you don't have a requirement. If you have a requirement like 100 millisecond time per minute, right? After the requirement, the next section can be high-level design. High level is how you can take the problem, how you solve it. Like we discussed the example of the children. You'll build the legs, you'll build the base, then you'll assemble it. This is the high level solution. And the low level, the next would be the low level, where you say that okay, this is my dimensions of the leg, each leg, and this is where I put the nail. This is where so these are the low level details. And after that, the last section can be appendix. Appendix is basically what are the resources you kind of refer to. So this is a very good template for any software design feature. Any more questions?
Okay, we can take one last question. So there are other sessions lined up. Okay. I don't think there are any more questions. There was somebody who was raising their hand. Any other question? Fine, then we will wrap up the session. And in case if you have any questions, we will be around so like we can help you out. Thank you for joining the session, and thanks to all the people who have joined us as panelists. So feel free to reach out to any one of us if you need any more details for this talk. Thank you.
So now, next question will be Mr. Karan will be based on my next one. We'll be starting in 5 minutes.
Sleep and attending flights have been working.
Technology that can run programs in a privileged context, such as the operating system. But what the physics is happen again also like that. मुझे वो लोग बैठ के the progress on the customer cases तो बंदा मुझे सोचता है must have been supposed to know how to optimize it and like if you want to learn more type this take a note of this मेरा इंटरव्यू चल रहा है एक ही मेरे लिए
हाँ हाँ आ गया आ गया आपको पीपीटी करके
हाँ नया प्रेजेंटेशन बेसिकली
वो
यहाँ पे है क्या ऑलरेडी? हाँ उधर से कर सकते हैं।
आप स्लाइड्स हैं तो आप इसमें ऐड करें
So how
और
do I add
स्क्रीन
that?
शेयर कर सकते हैं।
सर वो हो नहीं रही उस टाइम आप देख हो जाती है
स्क्रीन ब्लैंक चला गया, क्या ये कनेक्ट नहीं हुआ? विच वन वुड यू लाइक? एंटायर स्क्रीन
हाँ you can do it. Yes, करो.
एंड आई स्विच ऑफ द वीडियो। दीदी स्क्रीन बदल कुछ और हो एक बार। क्रोम की जगह कुछ और हो। हाँ हाँ चल रहा है। हाँ नहीं आ रहा, यहाँ आ रहा है। विकास इसको मूव कर। हाँ इसको चार्ज नहीं।
इसको वहाँ ले जाओ
हाँ
इसको
इसको मूव हो गया स्टेज पे जाके करना। वो क्या बोल रहा है?
जो इसे अंदर करते हैं स्टैंड भी कर रहा है
नंबर कर रहा है फिर चल रहा है।
ये इसकी बात
चार्ज में लगा इसको।
Good afternoon, everyone. We are going to talk about the deliver on line external DBA conventional cases. He is an RC engineer at Breakout and a line external contributor. Please give him a round of applause.
Okay, so let's get started. Another technical talk what we of the counters and we are with me. I'll make sure that it is interesting and I deliver many sessions in open source implementation.
by 2024, all Microsoft Windows systems came down because of a problem in one of their security software, which was from CrowdStrike. So basically, the reason I put this slide is, if you are doing something in the kernel level, the amount of thing that you have to take care, the disaster it can cause is humongous. Okay, so understanding Linux kernel, understanding while writing software for Linux kernel or any kernel software is very, very important, and we have to be very, very careful for that. Okay, so I'm going to start with some basics so that even people who are just starting an operating system, they would be able to understand the future part of my talk as well as the slides. So this is a very vague slide. It talks about Linux system calls. So let me tell you how Linux system works in 2-3 lines. Everything that you run on Linux operating system or any Unix-based operating system works using the concept of system calls. So whenever you run any application, it needs to make some kind of system calls, and the system calls are made to the Linux kernel. Okay, and every system call that is made from the operating system goes to the kernel, gets the response from the kernel, and comes back. And this happens within nanoseconds or microseconds of time. There are a lot of operating system calls or the system calls that are made. So you can see on the left-hand side something called as user space. These are applications. This could be any application. So you run a terminal command, you run Firefox, whatever is running on my machine, everything is running on Linux. That makes a system call, goes inside the kernel space. Kernel has to make sure that it is working correctly and it is following the security principles of Linux kernel, and then only it gives back the response correctly to the user space so that it can go ahead. And this happens within nanoseconds of time. Okay. Now, why I talked about Linux system calls, because that's how every operating system works. Now, if I want to do some kind of development for Linux kernel or for Linux at the system level, so let me tell you some kind of maybe some history. Earlier, whenever somebody wants to develop something on the kernel, there is a way where you can do changes inside the Linux kernel, and there are various steps that you can execute so that you can recompile the kernel. Okay, in order to recompile the kernel, you have to configure the kernel, you have to completely build the source code of Linux kernel. We have seen some talks or workshops that are going on where they are talking about rebuilding the kernel. Okay, and then you can run your own operating system on any machine. Okay, that's the procedure. Sorry. Oh. That's because of the extension that he's saying. दूसरा port try करना है कि वहाँ पे there are 4 ports अभी on the right hand side also there are ports. Maybe, yeah, that could be the thing. Do you want to try this? Okay, thanks a lot. Okay, so let's continue. What I was talking about is there are ways where you can add changes or make modifications, enhancements into the Linux kernel. You can do the development of Linux kernel. There are multiple ways of doing that. One of them, you can directly make changes into the kernel, recompile the code, and then load it on the device. It could be laptop or it could be even embedded device or IoT device, and make sure that you can debug your changes, or you can verify your kernel changes, and then contribute back to the Linux kernel. There are other ways of doing that. Second is called as kernel modules. You can write kernel modules. So kernel modules are nothing but a way or a functionality that can be inserted into the Linux kernel at runtime. So I have a kernel which is running, okay, and I can insert something into the kernel, okay. It is called in medical terms like open heart surgery. Already something is running, I am basically making some changes into that. But then kernel will not allow to make any mistakes over there, and that's where you can, whenever you are writing kernel modules, you make sure that you are writing it correctly, and kernel takes care of all the security aspects or all the aspects which will not break the kernel, okay. So that's another way of making changes into the kernel, that is called as kernel modules, okay. So these are basically some of the things that we have been doing in the past, but recently, like, of course, after it has been almost 10 years now, but there is a concept called as BPF programs, okay. BPF stands for Berkeley Packet Filter. This was a networking technology in the Linux kernel. It was later on extended for other subsystems of Linux as well, okay. So eBPF stands for Extended Berkeley Packet Filter. So you are going to extend the functionality of the Linux kernel by adding some kind of features, some kind of functionality, or you can read from the kernel and make changes into the Linux kernel. That's the ability that BPF provides to you, okay. Is it clear what is BPF? So that's the concept of BPF. Now we'll work on figuring out how I can make use of BPF. Can I make use of BPF for what kind of use cases we are having, and where can I use BPF code, okay. So that's how we are going to delve into the interesting things about BPF. So as you can see over here, if I want to develop something at the Linux kernel level, I have to write some kind of BPF code, okay. Now how do I write BPF code? How do I insert that code into the kernel? And how do I make sure that the code that I'm inserting into the kernel is following the principles which are imposed by the Linux kernel, okay. So there is something called as JIT compiler, okay. JIT stands for just-in-time compiler. Now this is something which is built into the system, and you don't have to worry about basically understanding the details about that. For example, whenever you are writing applications, you use GCC compilers. You can always use GCC compiler in the similar fashion. You can use the JIT compilers, okay. So whenever you are writing any BPF specific program, you can write your code. I'll come into I'll basically even show during the demo what kind of BPF programs that you can write. There are existing BPF programs that you can use as well. You compile that program using JIT compiler, and that goes inside the Linux kernel. Now in the Linux kernel, there is something called like a eBPF virtual machine that runs and accepts these changes that you are putting inside the kernel. So it's the same philosophy of open heart surgery, where a kernel is running and there is somebody who is going to accept changes, but it's not going, he is not going to accept the changes as is. He's going to do all the verifications. He's going to run all the checks that you are inserting as a BPF program, and then only he's going to allow that. Once that is done, then you can get the data from the Linux kernel by using some kind of technologies which is called as BPF maps or BPF programs and so on, okay. So that's basically the polling of the data. So if I want to read something from the kernel, I'll push a BPF program. Once the BPF program is found to be sane, I can poll the data using some kind of BPF program, okay. That's how you do BPF programming, okay. So let's see some things, whatever I was talking about here. So BPF is basically a network packet filtering, but extended the ability to call kernel functions during around 3.15 kernel cycle. That's the reason the name is extended BPF. It's basically a subset of C and compile into byte codes. Why it needs to be compiled into byte code? Because that's how the byte code gets converted into the kernel native code inside the kernel. You see, kernel is already running, so there is a binary that is running as far as the kernel is concerned. You have to convert this byte code into the kernel native code, and then only it can run inside the kernel, okay. So eBPF sandbox is nothing but a virtual machine that can copy the data into the sandbox and to perf ring buffer, and user space can read from the buffer. So we'll go into details about this. So whenever we push the program, it goes inside a VM kind of thing, and there are basically performance or perf buffers that are maintained, and the information from those perf buffers can be read back. There was a polling data picture that we just saw in the previous slide. Now, in order to do all of these things, we need to have some kind of tools. Okay, I talked about JIT compiler, I talked about verifier, and so on. Okay, these are all the tools that are already done. Okay, so we need some kind of tools for that. There is one of the tools is called as BCC, which is BPF compiler collection. Okay, and this has the built-in support for the LLVM, which is nothing but your JIT compiler, and the CLang, which is a different compiler. Okay, now those who don't know what is LLVM and CLang, it is very similar to your GCC compiler, but only thing is that it's able to understand the language in which the BPF programs are written. Can you please just I think okay, thank you. Okay, BPF trace is another tool that I'll show the demo as well. It's basically a tracing language and it is very useful. And then kernel code is what we know. Okay, so we have seen that we can write some kind of code and compile that using a tool called as BCC. Okay, so let's look at the diagram only. Okay, you can write your code. Now the code you can write in C, C++ as well as there are other languages supported. So you can write your code in Golang, you can write in Lua, you can write in Python as well. So there is no restriction. But look at the way from the functionality perspective. Linux kernel gives you a functionality where a code that can be written in Python can be inserted into the kernel after doing the compilation. Okay, using the specific compiler. Okay, so that's how the BCC tool is very helpful, where it can be used for sending the code from the user space to the kernel. And you can see on the right hand side there is BPF bytecode that gets inserted with the help of the BPF shared library, and it gets written into the kernel as BPF maps. Okay, now who updates or who writes into those maps? You can see the red line. It is done by use of something called as kernel probes or the tracers. Okay, we'll go in details about this. So till now we are able to write code, push into the kernel, get data from the kernel using BPF maps. Okay, that's how the BCC or the BCC compiler can be used for dealing with pushing of the programs into the kernel. Okay, just a recap, where are we talking about? We are talking about the kernel code. Okay, and applications are at the higher layer. Shell or basically your terminal is there, but all changes are happening inside the core part of the kernel, which is nothing but the ring 0 of the operating system. Okay, and that's where our main operating system is there. We're going to add kernel module functionality using insmod. We can add or device driver, but what BPF does, it does basically reprogramming of the kernel without source code changes or loading of the modules. Okay, just a small slide, just gives a different perspective of how BPF as a concept gets used. Okay, I'm going to just show this slide for some time because when I say or when I talked about BCC is an older tool. Okay, basically it required you to compile your code or basically use some kind of compilers which can be used to push the changes into the kernel. And recently there has been some development in the kernel where you don't have to do the recompilation as well. Okay, you can do something called as CORE, which stands for compile once, run everywhere. Okay, so that's basically a concept of CORE. The only reason I put in this slide is if you start looking for BCC, you might find that BCC is an older tool. Okay, and the industry or there has been somewhere new ways of doing BPF programs, and that makes use of the functionality called as CORE in addition to the libbpf library. Okay, now in order to understand the BPF concept, yes, it's very important to understand the concept of BCC, but BCC is like a compile time thing, while libcore it basically just does one time compilation and runs everywhere. Okay, that's the advantage. So even earlier, let's say if I want to push a BPF code for a specific kernel, I'll have to compile once with BCC. If I want to push a code to different version of the Linux kernel, I'll have to recompile again. That was the change that was required with BCC. But with libcore, what happens? You compile the code only once and run in any kernel. That's the meaning of running on everywhere. Okay. So quickly, I'll just go through the differences. it basically it had the Clang front end. You can directly use libbpf library, which is provided by the CORE. You need to remember naming conventions, automatically generated trace point structures, and everything. libbpf or the core library basically gets even rid of that. Okay, and it basically used to take a lot of CPU cycles and memory resources to compile the BPF program. Nowadays, it's not required because of the core functionality that is available. Okay, so from understanding perspective, from the concept perspective, BCC is good. That's where I got to know, okay, how the programming works for BPF programs, how I can push the changes. But while you're going to use it, look for the core things. Okay, those who want to know much more details, now I have talked about basically writing code, pushing it to the kernel, the GIT compiler, and how the program works inside the kernel. If you want to go deeper into that, there is no limit. In Linux kernel, everything is open source. You can always see what is happening and so on. If you want to see more details about that, you can always see that as well. The way it works, it's the BCC compiler. Okay, then basically probes gets loaded. In the BPF program, there is something called as libbpfc file. Okay, that makes use of a system call. You remember we talked about system call. Anything we want to enter into the kernel, we have to use system calls. Even if you are opening a file, you are making a system call called as open. Okay, for BPF, there is a new system call that was introduced. It's called BPF system call, and that's basically gets loaded inside the kernel, and the maps are created using those Clang or LLVM compiler. This is all low-level details. The most difficult thing or the most internal thing to the Linux kernel. If you want to go to that level of details, you can always go, and that's the reason I included this slide, so that there is no limit if you want to understand the lowest level of details. Okay, so that was about the concept, and as a whole, how I can make use of BPF or write code and enhance the functionality of Linux kernel, read what is happening inside the Linux kernel, and so on. Now, why do I need all of these things? Okay, so let's say typically in a system programming industry, be it networking, security, storage industry, or even cloud computing, and everywhere you need to understand the systems at the lowest level of details. And if I want to basically find out what is happening inside the systems, there are some programs that are available. I can run top command. You know what is top command? Top, you can see what all processes are running. You can run how much CPU is getting used by each of the processes. Are there any shared memory that is getting used, and so on. So earlier there were a lot of commands, whereas or simple commands those are available. But with the BPF coming or the invent of BPF, what has happened? There are multiples of tools that are available, and these are provided by BPF Trace. Okay, so BPF Trace is a library that is written by Brendan Gregg. Brendan Gregg is a performance engineer at Netflix, and he has written this library, and he has provided a lot of tools. Now, if you want to find out the performance of a system, whenever you work at the system level, the performance is a key factor. There are specialized performance engineers who are working on figuring out, can this piece of code run in 1 nanosecond instead of 2 nanoseconds. So that level of requirements are there, and that's where we need to understand what is happening at the system level. And there are multiple tools that are available over here, and all of these tools are provided with the help of BPF programs. Now I'll show you you can get these tools on your Linux machine very easily, and how you can even make use of those tools, how you can write your own tools, and where are those tools can be used. Okay, so before going into the tools in details, let's look at various kernel level things that we need to look at from Linux kernel whenever a BPF program gets written. Now, I talked about kernel probes. Whenever I was talking about the internals of kernel, Linux kernel, I talked about kernel probes. So these are basically nothing but instrumentation tools inside Linux kernel. So you can find out what is happening inside the operating system by using this kind of tools. And there are various instrumentation tools that are available that can be used for this purpose. And these are of two types. One is called as dynamic, other is static. So in the kernel space, there are kernel probes that are available. In the user space, there are user space probes available as well. there are some kind of trace points. Now, trace points are very easily available in the kernel, and even there are user space. In the user space, there are user space statically defined trace points as well that are available. Now, these tools are available, and I can write BPF programs related to each of these. Yes. Sorry. Okay. So there are various kind of trace points, kernel probes, breakpoints that are available. So if I want to, let me give an example why I'm talking about these things. Let's say I want to figure out, okay, let's say, let me give an industry standard example related to cyber security field. Okay, I work in cyber security. For example, I want to figure out, or whenever I'm writing a next gen antivirus, I want to figure out what all applications are running and are they trying to open any files in my system. Okay, what I'm going to do, I'm going to write a BPF program to monitor if any new file is getting opened. Okay, so what I'm going to do, I'm going to track all the open files inside my system, and then if I find that a file or a malicious file is opened or a file is getting opened by a malicious program, then I'll deny the access. Okay, look at this as a use case from cyber security perspective. Okay, so for that, what I can do, I want to deny the open system call, right? Because that's the open. So I will have to write a kernel probe for the open system call, and then see if the program that is accessing the open system call or the program that is making the open system call is a valid program or it's a malicious program. And if it is malicious, then deny the access. Okay, that's where you need to understand what kind of probes you need. You need kernel probes, you need kernel return probes, you need user space probes, and so or trace points. So there are various instrumentation tools that are available, and you can make use of these tools in your BPF programs. Look at the, I just talked about one of the use case of BPF is the cyber security, okay, or that is called as observability. So you write observability as one of the use case, and over there BPF programs can be used. It can be used in any other industries as well. So for example, networking, software defined networking, lot of BPF programs can be written. Okay, then container security, you can write programs as well. Then device drivers, you can write BPF programs as well. Okay, so I talked about the use cases of BPF programs. There are security, intersystem the system call, like the open system call, monitoring, observability, looking into what is happening inside the system and so on. Okay, and tracing and profiling. Okay, I'll quickly go for a 5-minute demo to show where you can get started with a BPF program. Okay, I'll have to type with one hand, but that's okay. Okay, if you want to start with BPF programming, get started with this tool called as BPF trace. Okay. Oh my God, what happened? It's not taking my commands now. So install a program called as BPF trace on your system. Okay, this is the name of the program, BPF trace, and there are a lot of programs which are available in this. So I'll just show you quickly. For example, let me give you an example. Okay, I'm going to show you one example for which is called as exec snoop. Exec snoop is a program, or it's a already built-in program for checking what all executions are happening. I gave the example of cyber security. So I want to see what all executions are happening inside the system. So there is already a BPF program available. So user has been exec snoop.bt. BT is nothing but the BPF program, and it contains the source code for that. So you don't have to even write your own source code. There are source code available. Okay, you can see what it is doing. It is tracking the sys_enter_exec star. So it is tracking all the exec specific system calls. Sys_enter is the entry for it, it's the kernel probe for that, or it's a trace point for that execution of all the system call entry, and I'm going to write some code for that, okay, and get that information. So when I run this program, so there are basically syntaxes whenever you are writing BPF program, what code you can write, what test points you can use, what kernel probes that you can use, and so on. Okay. See, now can you see I have ran that program user has been exec snoop bpfcc. So it's basically printing. You just saw the code. It is going to print all the files which are getting opened, all the programs that are getting run, and so on. So if I run a new program over here, for example, if I run, oh sorry, I'll have to log into my machine. Just 1 second. This is my VM. So I ran ls, and you can see there are so many programs that are seen. Even the ls program that I ran is at the end. Okay, so it is snooping all the executions. So it will be able to execute all the snoops and everything. Okay. I'm just showing basically what all tools are available over there. Okay, let's run a simple command. Okay. So I ran basically a command to display all the BT files or the BPF codes which are available, and using this you can run any of these programs. Okay, for example, and figure out, okay, now these are self-explanatory. There are man pages available for them as well. For example, if I run the man and let's say loads.bt, it is showing a man page for loads.bt. It is basically showing to show what is the load average on your system and so on. Okay. All these programs which are written over here as a part of the BPF programs are available. Now, in order to write your own programs, the first thing is that you can get started with existing BPF program, run them, see how they work, and then you will figure out, okay, this is how you have to write. Then you can find out your use case. Okay, now this is the use case that I have. As far as my BPF program is concerned, then I'll write this kind of BPF code, and then once I write the BPF code, then I can execute that as well. Okay, so now you have got the control of the operating system by means of inserting the programs into the Linux kernel. Okay, that's how you can execute, write, and see what is happening inside the Linux kernel. Okay, so I'll stop here. If you have any questions, you can ask, or you can even connect me. Yeah. Inside a container, yeah, you can run the program inside a container. Yes, so see, BPF program doesn't basically restrict from running from inside the control. You can access the host. There is a volume mounting that is possible. You can share a volume, and that is possible. So what I mean to say is that BPF program and container restricting things are not related. You can, I mean, we have use cases basically. We can do, let's say, as a part of our product, basically we see what all containers are getting spawned and report all that information to the cloud software, basically, which takes care of the cyber security. Yes, that is possible. Okay. Yeah. Thank you. Sorry. Oh, sorry. Sorry. Little.
This one. Yeah, I'm the. The detector meter. Oh.
Yeah.
Okay. इधर टाइप हाँ सर
You guys still need
screen share is working. अभी जब जो गए उनसे तो ले लिया हम लोगों ने
पहले कौन
Okay.
Now we have a session based on social competitions and career opportunities, and also having Mr. Australia and Mr. Porter who are discussing. Please welcome them.
Thank you. Okay, thank you, everybody. Maybe let's start. So,
This is for the screen. We'll record the voice.
लेकिन तीन लोग के लिए शेयर करना है.
That will have to change it.
I'll catch this like this.
I think it's supposed to. It'll record your voice. I'm not sure how it will work. Just put it. That's it. And then.
okay, yeah. I'm sorry. Okay, I'm sorry. Today's topic will be, oh my God. May I start? Okay, finally, let's start. So today's topic is like contributing to open source insights and opportunities. So agenda will be like we'll introduce ourselves and also our tool, and then we'll talk about Google Summer of Code, and then speak more about like corporate and open source relationships. So let me start with our introductions. So I'll start first. I'm Shaheen Ajmal. So I'm working as lead research engineer at Siemens Technology and Services Private Limited. So I'm based out of Bangalore. So I'm a technical lead to Fossology project. I'm contributing to open source since last 11 years. And yeah, my day-to-day work will be like interacting with different customers in the community and then creating nice features out of Fossology. And yeah, apart from that, I do some research as well. So I like to do research in the topics of AI and ML. So yeah, I think that's it. Maybe Gaurav. Yeah.
Hi, Ramesh. I'm also a research engineer at Siemens. I'm working at Siemens for past 7 years, and apart from that, I'm in the open source world. I play different roles. So I also am a maintainer of community. I'm also a community leader for a different project, owner for several open source projects, as well as I also play the role of mentor. In my research area, if you are interested, so I work with different technologies like DevOps, software architecture. Lessons compliance is my major domain. Also includes software and generative AI. So I'll hand over to Kaushal.
Thank you. Hi, I'm Kaushal, and I'm also a research engineer at Siemens, and I've been contributing to open source since past 6 years. And my research domain in Siemens basically involves machine learning, artificial intelligence, and very jumping of generative AI uses. And yeah, so my major role in the company is to drive innovation to open source, and that's what we'll be talking about today, how Siemens is basically supporting that.
Thank you, Kaushal. So maybe let's continue with Fossology, so introduction of Fossology. So what we do at Fossology, we do license compliance, and here we are not going to give any legal advice to you guys. So let's proceed. And how many of you have seen this brochure? Okay. So do you guys think there is something missing here from the compliance perspective? Anybody? So yeah, so whenever you download something from the public domain, you need to provide the copyright, and also you need to acknowledge the contributors as well, and also read the license text, and yeah, provide attributions to it. So this is what is missing here. So we make this easy for software. We do compliance. Our tool Fossology usually scans for this type of licenses and copyrights. So let's proceed further. So from the software perspective, I think it is not very easy to find this type of licenses because you all know that distributing an open source software requires to provide licenses of involved software, provide copyright statements, provide disclaimers, and many more things like acknowledgements, obligations, and many things will be there. So how many of you have already seen the legal notices? It's like on the other side of the screen, at least in your mobiles. Okay, maybe from the mobile, I think it's a little hard, but most of you will have the Instagram. So in the Instagram, if you go to settings, in the about section, you will be able to find all the legal notices that are involved in the Instagram website. So maybe you guys can check later. So it's all about finding licenses. So this is how it looks in actual software. So this is the reference text of the license. So usually we find license text, reference to licenses, and written text explaining licensing, and then license relevant statements. And yeah, so to start with, the Fossology project was first published in 2008, and in 2015 we became Linux Foundation Collaboration Project. And we provide web server based and command line based as well as REST API interfaces. So scanning agents for searching licenses, copyrights, export restrictions, and custom keywords as well. So we have a multi-user, multi-tenant based web UI for reviewing and organizing your licenses. So our development stack will be pretty much standard, like we have Linux, Apache 2, Postgres, PHP, and yeah, Python, Go, C, C++. So we provide YouTube video where we explain about the basic workflow of Fossology. If you guys would like to have a look, maybe you can just search for Fossology workflow in YouTube. You will get a video, so you can watch about it. And we also have some nice, good first issues and also a Slack channel, so where you can join and explore the community. So this is the flow of Fossology and how it works. So usually you need to have a open source component. And then review the results and generate the report. And usually you pass this report to the customers. So uploading open source might be with zip tar, and then agents you select like Nomos, Monk for license scans, copyright export control, and maybe your keyword scanning also you can select. And then once agents runs, you review this results for wrong classifications if there are any. And then you review the scanner findings of copyrights, ECC, and IPRA. And then you download the report. So reporting formats, we provide our SPDX reporting. We have README format, and we have Debian copyright format, and also the Cyclone DX format. Yeah. Okay. I think it's back. The main overview of the features, if you see, we have a regular expression scanner, which is Nomos. We have a text similarity scanner, and we have a nice view for organizing and managing your license text. And we have an aggregation view or hierarchical view for found licenses as well as the edited licenses. And we have a license histogram, so where you can see how many licenses that are identified by an agent, and also how many how many licenses you have changed, and the count of it. And also we support bulk processing of files with same licensing. So you don't need to go and clear each and every file with same license, but you do bulk processing. And then we also support reusing of license conclusions for different versions. For example, you have X version cleared already and X.1 version released. So you clear it by reusing the X version. And other features like copyright, authorship statements and scanners, and export control, as well as the custom scanners like keyword. And coming to the reporting, in the SPDX, we provide RDF tag value, and also with the versions 2.3, and currently we are going to support SPDX 3.0 as well with the JSON format. And we have Debian copyright format as well, and README OSS as well as the Cyclone DX format for reporting. We have a nice UI where you can manage the groups, upload management, as well as the user management. So additions to Fossology, we have created newer agents like Ojo and compatibility agent. Ojo usually scans for SPDX license identifier, and compatibility agent clears your component using the license category, like if the license category is permissive or copyleft. And we also provide integration with other projects like clearly defined scan code and scan OSs. So maybe we'll discuss this about this project later. And we also support more data exchange formats like CLXML, Cyclone DX, and decision dump JSON. So decision dump JSON usually provide you to copy the results from different pathology servers. And we have very new improved REST API version 2, and addition of projects like Safa, License DB, Minerva dataset, and we have many more features. So, yeah.
And like maybe invite you guys to come up and contribute, because we have a variety of projects that we need your help, and maybe I'll also be explaining that. If you are interested, maybe come up to us, please contribute. Next year, Google Summer of Code is not just one program. You can always be an open source contributor. So yeah, this is just a quick introduction, but I know most of you might know about this. So what I also want to focus on this is the global reach and the open source contributions. So if you see the global reach that Google Summer of Code has provided for students who have been working, who have been studying in any years. So now I might also add the working professionals as well. But yeah, over 20,000 students from 116 countries have participated in past 20 years Google Summer of Code, which is a huge amount. And for an organization like Google to support open source on such level is very interesting. And then open source contribution is important. Why I say that? Because if you see a lot of open source organizations, their inceptions has also started through Google Summer of Code itself. And being part of a key component or key machinery, and which started through Google Summer of Code itself, is a huge deal. Yeah, so you might have heard a lot about Google Summer of Code timeline from a student's perspective, but I wanted to give you a different perspective here through an organization. So we as an organization, how the preparation looks like from our side. So if you see, it starts with gathering ideas, because the involvement of the community basically defines what open source is. So we invite all our contributors, all our stakeholders. They come into one place. We discuss what are the challenges or the problems that we want to solve for that specific year. And after gathering those ideas, we document them at a place, and then we move ahead to the idea selection for G-Shock. So basically, it includes filtering ideas, moving to the wiki, opening the relevant issues. And after the finalization, there is a stage for preparation of application and dedicated space in Slack. So our community runs on Slack, and that's where we open specific channels, we open specific issues which are linked to that, and people can come over and discuss regarding that. And when it comes to the proposal stage, once you people submit the proposals, if you like any idea or anything, once you guys submit the proposals, there is a review session that happens with all the mentors. And once all the mentors give a go ahead and give reviews, then only we rank the students according to the requirements. Cool. Again, one more perspective that I also wanted to show. It's, I think, very important, because you sitting here just think about GSOC as a contributor, but you can again be a mentor as well. So I want to give you both perspective here. So if you see, for students, it gives a beautiful experience in software development, because when you talk about corporate, or maybe if that's what you want to do in your future, the software development life cycles, and the other mechanism related to it, the developer operations, the other operations that are included in it. You learn about that in your internships or in a real life scenario. That's what it gives you. It's a real life scenario where you can learn about that experience, and you can also, again, with your own will, as they say in open source communities, uh, if you want to take something from the community, you should always be, willing to give it back as well. So that is like participation in open source initiatives that is also included from your side. And again, all 3 points are related to that also, that you get an internship like experience where you have a distributed environment where people are like, so you take an account in your personal project. You contribute like 1 commit a day, 2 commit a day, or let's say you sleep for 3 weeks and then you don't commit. But if you look into a organization like us, once you sleep at night, when you wake up in morning, you will have 200 commits that will be done by someone or somewhere else. So that's where the distributed environment comes into the picture, where you have to learn how to parallelize your tracks, how to parallelize your branches, another kind of work that you will always see in your corporate world. But for mentors, so mentors is a positive visibility. So as we say in corporate, this is a saying, so leaders and mentors are very different, right? So this is a positive visibility in a sense that it helps you overcome the challenges in a way that you already know that the other person is facing, and then you figure it out in a way that the other person won't feel dumb or anything, little about it. And that's a learning. Trust me, that's a learning. I've been a mentor for like 4 years now, and it's a huge task. It's not easy. So that kind of learning is very important in your entire corporate career if you want to have. And then yes, the opportunity to work on new technologies, because most of the organizations are switching from the older technologies, and the code bases are written in very old technologies. So that is also an opportunity for you to learn something new. Okay, so this is a trend graph for Fossology. So we have started participating in Google Summer of Code in 2018, and the above line is the student that has applied to our organization, and the the line in the between is for the mentors, the number of mentors that we have, and the below the line that we have is the students selected. And you can see it's a growth in progress. So there is a point somewhere in 2023 where you see, sorry, 22 and 23, where you see a lot of students applying, but not a lot of students getting selected. Is because that's when Google started projects for the students as well as the corporate employees. So the number of projects increased, and the number of seats given by Google was not enough. So yeah, that is a trend from our side. But if you see constantly from 21 to 24, we have almost 10 students working with us. And from like 3 or 4 years, we have 10 to 12 ideas that we want to integrate or work on for our organization. And they all include versatile tech stack. So yeah, I want to also like, Fossology is an umbrella organization with a lot of projects that come into it, and with a variety of tech stacks. So I'll quickly go through the projects that you can face once you come up as a contributor, or once you come up as a mentor as well. So if you find any of it interesting, please reach out to us, and please reach out, or please start contributing. So Atarashi, so Fossology, I think Shaheem mentioned before, it's a rule-based tool. So we use a lot of regex and other rule-based approaches to figure out the licenses from the code text. And Atarashi is a different approach to that. So it's a non-rule-based standalone processor where like we use a lot of mathematical approaches and a lot of machine learning based approaches to find the similarities and the distance between, few of the NLP techniques to find the distance between two statements as such. And trust me when I say it's not an easy task. License statements and copyright statements are the toughest data set you'll ever come through. If you don't believe me, you can go ahead and try on your own, and it's huge. So yeah, it's we use a lot of algorithm like word frequency similarity and n-grams, score similarity, cosine similarity, and all of this on a basis of benchmarking. Yeah. Then there is one more term that is there with licenses, that is copyrights. So I think all of you might know what is copyright, and one great real life example also we showed in the beginning. But in terms of software, right? Before giving any of this, I want to show you this example here, the captured and the cleared. So if you see on the first section, you see this is a copyright statement, which is of like 3 lines. It has a copyright specifically mentioned with the copyright and the date and the corporation which it's copyrighted to. And it also has a lot of clutter that is there. Now, this tool Safa that we have is basically to clear all that clutter if that's a valid copyright. And that's where you see the output of the Safa project, where it just keeps the copyright and removes all the clutter. And the second is the false positive. As Fossology uses regex-based approaches, false positives are like, we always welcome them because we couldn't do anything in those regards. One of our students came up with this approach to, have false positive detection. Before that, we also had some false positive detection, but that was not as efficient as it was. And it's a pure machine learning based approach where we are using some models. We are using stochastic gradient descent and some of the techniques like named entity recognition and the pause tagging for this. And this basically is, if you guys are interested in machine learning, NLP, and if you're planning to contribute in those sections, you're more than welcome. And this again is a different side of tech stack. So scan code, like for Fossology, we have Nomos and Monk. There are other tools out there or other scanners that are out there as well. So this is a community outreach kind of a project where we reached out to the other community who is doing the same kind of work. And ScanCode Toolkit is basically a very well-established license scanner. And we reached out to them so that we can also use ScanCode. And there is a basic idea to use their command line interface and connect it to the Fossology and use it in a way that there is one more scanner and one more scanner support from community. And that is what we also need in future. Multiple scanner supports, multiple detection supports, multiple report supports. Yes, so clearly defined is basically a public domain where if you have a component, all the information regarding that component should go to a public domain. When I say information, all the license data, all the copyright data, all the obligations should go to that domain. So we gave a support to the Fossology, we gave a support through Fossology to the clearly defined. And that is one more project which was entirely different tech stack. Maybe, yeah, I'll go to the post GSOC. So this again is very simple. What we want is, see, post GSOC, we support our contributors, we support our students to basically, reach out and be a messenger for the community, because our community is not very large. The tool is being used by a lot of companies, a lot of organizations, but we need a constant support from contributors. So these are our voices, people who are going out and having a lot of writing blogs and creating videos on YouTube to set up and community outreach. So these are some previous students that we had who helped us in that. I don't think we have a lot of time, so I'll quickly give it to Gaurav. And thank you so much.
Okay. So thanks. Yeah, as my colleagues Kaushal and Shaim have explained you about various aspects of the software, like the Fossology community, Google Summer of Code, and how the open source software play different roles in different stages. So I would like to take a slightly different route and show how corporates also get involved in open source. So it is not just like every corporate is evil. So, yeah, not to get into details, but yeah, we just do not consume open source, but we also like to give back as well. So that's all open source is about. So for example, Siemens, we started with inner source, which is about a culture which is similar to open source, but within your organization. So earlier we had specific silos. So certain set of people will work only on certain set of softwares and no code is shared in between. Then slowly the culture of inner source got introduced where we started sharing code within the organization amongst different projects. So reusability improved a lot. Even the faster delivery started to come into picture. But now we are moving towards open source as well. So fairly recently, Siemens announced their open source manifesto, where we talk about our company principle and employee principle. So from company's point of view, we are encouraging our employees to put more and more efforts into open source. So many a time you are going to use any open source software. Let's say you are using Kubernetes, and in between Kubernetes, you came across some issue, and you managed to, since it's part of your product, you have to fix it. So you figured out how to fix it. And so earlier days, this is where you generally stop. Because you have to take a lot of routes, reach out to your manager, reach out to your IP team, make sure there is no compliance issue. And then your manager may or may not approve you to push this code into upstream, make it open source. But now with this manifesto, Siemens is trying to make it very easy to contribute back to open source. Also talking about culture inside Siemens. So you can see the first line, it says upstream first. So within Siemens organization, we use GitLab to maintain our code repositories, even the community edition of it. And because of that, we have a very big pool of users which use GitLab, and that allows us to come often to very a big pool of bugs as well as a big pool of new feature requests. So we have dedicated team, let's say inside Siemens, who maintain the server, collects all this information. So what upstream first means, we whatever change we make, whatever bug we fix, whatever new feature request we make, even the same we follow for Fossology. We first make it open source. We first put it on GitHub, on GitLab, whatever the platform is, and then we pull it back inside Siemens. So that is one of the culture being followed. I think many other organizations do follow the same thing. There is also a sharing culture. So you always want to share your knowledge out. And also culture of using open standards. So since Siemens is an engineering company, we work with a lot of industry-related hardwares, industry-related protocols. So we want to make everything as an open standard wherever it is possible. So this is not, open source is not just about putting your source code on GitHub, but it's bit more as well if you look at a broader perspective. So just wanted to mention one more aspect which Siemens work with is sponsoring to different open source projects. So we have different programs running which also sponsored direct individuals as well as different open source projects. So yeah, you can check out these links. And just last slide about a specific project. Another project we use inside Siemens other than Fossology is SW360. So this is also an open source project coming from Eclipse Foundation, which is a software catalog, and it helps. So as Shaheen mentioned, Fossology gives you license and copyright information about a specific component, which is, let's say, a dependency of your software. So SW360 allows you to manage a list of all your dependencies, take data from Fossology and store it at a central location. So with SW360, why it's a good example is because you can see the list of companies which collaborate on this project. So like Siemens, Cardia, Toshiba, Bosch, they all work on the software aspect of it, the development part, as well as working on sharing the knowledge. So since this license compliance is often a very costly process, so any new industry which is coming into picture, it sometimes become very hectic for them to understand the different workflows, different processes. So yeah, we also share our workings and document it, make it open. So yeah, that's what I wanted to share. So yeah, this is a QR code if you would like to reach out to us on Slack. We have every other way of communication over here. So are there any questions from anyone? Questions regarding open source, regarding GSOC, mentoring, any aspect? If not, then yeah. So feel free to reach out to us through any of these links, and thanks a lot.
So the session now will resume after a while after the coffee breaks. Please join us.
Mine also being right.
It's okay. Hello, everyone. My name is Pierre Clisson. I'm very happy to be here today. And we'll talk about time flux and BCI, which stands for Brain-Computer Interfaces. So you might have heard about BCIs before. There is a very famous company called Neuralink with the infamous Elon Musk. So the field of BCI has recently received quite a bit of attention from the media. But beyond the hype, I would like to show you how you can achieve state-of-the-art results today without having any surgery and with only open source tools. So first, we will get just enough theory to know what are BCIs and how they work. Next, we will briefly review the kind of hardware you need to build your own BCI, and we will introduce a time flux, an open source Python framework for designing brain-computer interfaces. And finally, we will look at a practical example of an actual brain-computer interface along with demo and code. So let's get started. So brain-computer interfaces, what are they? So in a nutshell, the very simplest definition of a BCI could be a brain-computer interface lets you interact with the physical world using only your mind. So what does that mean, and what can we do with brain-computer interfaces? We can help people with disabilities to move and to communicate. We can learn to control a wheelchair or robotic arm with a brain. We can develop software to help us spell words with our mind only. Another field of interest using, oh, I don't know what happens.
Yeah.
Okay, it's back. All right. Okay, I'll avoid touching. So this is another very exciting field of BCI. People have been using BCI for post-stroke rehabilitation therapy. So how does that work? We will put an EEG headset on your head. So an EEG will measure the electrical activity of your brain, and we can use that to help people who have lost control of their limbs to imagine, for instance, hand movements. They're not able to move their hands because the nervous pathway has been damaged. But while we imagine hand movement. We can detect it in the brain, then we can activate a robotic arm, and then we can activate this kind of loop where we will imagine that we move our hand, and then the actual hand will move, and this will help people to regain control of the limbs. So this is an emerging technique. It's called a neurorehabilitation, and it's a very powerful technique to regain control after an injury or a stroke. Yep. Okay. Another popular example of BCI is to detect vigilance level. For instance, if you are about to fall asleep on while driving, it can help you train your attention, relaxation, different kind of meditation. This is called neurofeedback, when you are getting direct feedback from your brain. So intuitively, actually, we don't really know how it works, but intuitively, your brain will adjust to the feedback it perceives. So if we can detect your relaxation level, your attention level, and we can, let's say, play a sound when your meditation is reaching a certain threshold, you can learn meditation much faster. So this is another way to use brain-computer interface. Another one, of course, is just have fun. We can include emotion detection in games. And we had this fun demo a few years back where we fly a drone using our mind only. This is the general architecture of BCI. So first of all, we generally use an EEG headset to measure the brain activity. Of course, we can have a much better signal by implanting electrodes directly into the skull, but yeah, I already said we won't have surgery today. The next step is signal processing. That involves different kind of steps, but mostly we need to filter the signal to reduce noise and muscle artifacts. One thing that you must know is that the EEG signal is very, very low signal to noise ratio. So the kind of activity we measure in the brain is in the order of microvolts. So that means that if you blink, if you move your head, if there is a neon spot, it will affect the signal. So we need some DSP to reduce the noise and clean the signal. Generally, we also need to extract some feature. So that means, in most cases, dividing the signal into small chunks that we call epochs, and we can extract meaningful information from these epochs, and then we will send these epochs to a machine learning model, pattern recognition phase, and we will then classify the signal, and through an interface, the interface can be anything, it can be a screen, it can be a sound, it can be a robotic arm, we will send the feedback to the user. So we have this kind of closed loop where we acquire the signal directly from the brain, we have a pipeline to process all the signal, and then the information comes back to the user. So I don't want you to be afraid of this, but it's just one slide. How does an EEG work? So an EEG is short for electroencephalogram. So it's a recording of the electrical activity of the brain using electrodes placed on the scalp. So just in a nutshell, the brain is made up of cells called neurons. Neurons communicate using chemical messages, and these chemical messages change the electrical potential of the cells they connect with. So in a way, neurons can be seen at very tiny dipoles, very, very tiny batteries. And these changes in electrical potential create very, very, very small electric fields. And so small that it is impossible to measure the electrical activity of one individual neuron through the scalp. However, if a lot of these neurons are aligned and are activated at the same time, the electrical field becomes large enough and can be measured. So, usual metaphor about this. Imagine that you are outside of a stadium. You can't see what's happening on the field. You just know that two teams are playing. You can't really figure out what's the action on the field, but if you're outside the field and there is a goal or something, you will hear the crowd cheering. And maybe you will hear the crowd cheering on the left or on the right, or you will hear some happy shouts, or maybe some disappointment in the voices. So this is the kind of measurement we can have with an EEG. We can't really know that that a goal has been made, but we can know indirectly a goal has been made because we can hear the crowd cheering. So the EEG signal is a time series. A time series is a series of data points indexed in time order. So, of course, there are multiple ways of representing a time series. So on the left, it's just a pandas data frame. So the index are the timestamps, and the 4 columns are the electrical activity in the brain. Here on 4 standardized electrodes, the measurement is in microvolts. And this is how we can represent the detail. So, of course, it seems very noisy at first, but when we apply the correct algorithms and the correct way of analyzing the data, we can extract meaningful information from this kind of signal. So there are mostly 2 ways of analyzing EEG signal. The first one is in the frequency domain. So if some of you are in the electrical engineering field or have done some basic digital signal processing, you know that we can analyze this kind of signals in 2 ways. First one in the frequency domain, the neural oscillation. So you've probably heard about this, the so-called brain waves, where you have beta, alpha, theta, delta, and also gamma. And this corresponds to different kind of mental states. For instance, right now, if you are focusing on what I'm saying, you will have mostly beta waveforms. If you are a bit sleepy, you will see more alpha or more theta. When you're in deep sleep, we'll have delta waveforms. Advanced meditators show gamma waveforms also. So this is another way of analyzing the signal. And the other way is through the time domain. So the time domain, we just take the signal and we look at the shape of the graph. So this is a standard textbook P300 evoked potential. We'll touch on the subject a little bit later. But basically, we just look at the shape of the signal and we try to classify it with machine learning algorithms. So when we do BCI, we need some hardware and we need some software. So let's start with the hardware. So there are 2 components in a hardware EEG. First, we need an amplifier and then an electrode. So we have, again, different kind of electrodes. We have, so the state of the art implies gel electrodes. I don't know how many in this room have already had an EEG on the head in medical settings. All right. So probably if it was in a hospital setting, you had a gel-based EEG. So that means we put some electrodes, we put some gel on it. The gel, the purpose of the gel is to increase conductivity. But of course, this has some drawbacks. The first one being that it takes a lot of time to correctly set up everything, and then you need to wash your hair, etc. So because of that, the other solutions have been developed, such as dry electrodes. So that doesn't require any gel. The electrodes can be 3D printed in some cases, and the signal quality is not that good. So first we need these electrodes. Then we need an amplifier. The amplifier will transform the analog signal from the brain to digital domain. So we have a lot of different options. This is the kind of medical state-of-the-art EEG amplifier. Just for information, this cost about $20,000 on the left. On the right, we have also open source amplifiers. This one is based on an Arduino and hat, and it costs about $300. And still, we have good quality. So we start to see affordable solution, affordable EEG that you can actually play with and get actual results from. And a few companies have taken this opportunity and have started developing their own integrated EEG. Maybe you've heard about a few of this one, maybe probably mostly the one on the left, Muse, which is a device to with learning, meditation, and relaxation. All right, regarding the software, now that we have everything we need to acquire the signal, we need to process it. And I'd like to introduce TimeFlux, which is an open source Python framework that allows you to acquire and process biosignals in real time. So it's written in Python, so it works on macOS, Windows, and Linux. And it can be used for a lot of different use cases. The first one is data and event acquisition from multiple sources, because most of the time you not only want the signal from the brain, but you also want it to be synchronized with other measurements, other metrics, or maybe some stimuli. So you need to be able to synchronize everything together. TimeFlux is also able to present stimuli, which are synchronized with the data stream. It allows you to build biofeedback application, brain-computer interfaces, which are a general case of biofeedback, interactive installations, and so on. So the important thing to remember is that TimeFlux is not only about EEG data, it's not only about biosignals, it's about time series. So people have been using TimeFlux for other unrelated applications, such as stock market prediction or earthquake prediction, this kind of thing, because everything is a time series. So TimeFlux out of the box work with a lot of different devices. We support more like about 200 devices right now. So all kind of devices. This on the left is an open source EEG system. This is a low-cost biosignal acquisition, and then we have different kind of research-grade EEG systems, but it's not limited to EEG and biosignals. This is an eye tracker, and this is really fancy balance, fancy scale that we use for sport research. So again, TimeFlux out of the box supports about 200 devices. So in a nutshell, why did we build TimeFlux in the first place? First, we wanted something that fits well within the Python data science ecosystem. If you want to develop a BCI, I don't want you to have to learn new tools, new techniques, etc. So if you're already familiar with NumPy, Pandas, scikit-learn, this kind of open source tools, you can use TimeFlux. And if you don't know them, well, it's a valuable skill to acquire anyway. It's written under a very permissive open source license. It's an MIT license. So that means commercial use is authorized. Of course, we can debate about the best open source license. Personally, I'm a big fan of MIT and DSD, but some people prefer GPL that implies that all the derivative work is also GPL. But with this, you can develop your own commercial applications if you want. It's an independent project which is funded through consulting services and public grants. It works both offline and online. So it's just some jargon, but in the neurotech community, offline means non-real-time analysis, and online means real-time analysis. And it allows you, because it's written in Python with a very simple syntax, it allows you to really test an ID very quickly. So TimeFlux is easy to learn, to use, and to extend. If you are doing some computer science, you will already be familiar with graph theory, nodes, edges, this kind of thing. It relies on industry standards, pandas for 2D data, XRF for multidimensional data, scikit-learn for machine learning, lab streaming layer for streaming synchronized data for science. It uses descriptive pipeline, so no coding is actually required unless you want to code your own module. It's very simple YAML syntax. I'm sure everybody here knows about YAML. If not, you can really learn it in 5 minutes. And if you want to extend TimeFlux, it's a custom module is just a standard Python class with one method to extend. So it's really, really simple. We do our best to provide good documentation. It's not perfect yet, but we are slowly going there. So we have some tutorial, some examples. We try also to document the API as much as possible. And it comes with everything you need to get started, including networking tools. So the publish subscribe protocol, we'll talk about more a bit later, LSL, OSC, WebSocket, etc., etc. It allows you to record and replay data in a very robust file format called HDF5. Of course, we provide many tools to do DSP in real time, machine learning in real time on time series, and we provide tools to help you build user interfaces that are available from a web browser. Again, we have a lot of tools that allow multidimensional matrix manipulation in real time. We already mentioned the 200 devices we already support, the sub-millisecond time synchronization, which is very, very important when you're doing ERT research. And if something goes wrong, of course, there are a few debugging tools that you can use. And if you want to plug TimeFlux with other systems, you can either develop your own modules, but you can also use what we call hooks, which allows you to launch an external application before or after you launch TimeFlux. So maybe you want to automatically upload the data files on a cloud server after the acquisition, or get some information about the subject, etc. So you would use hooks for that. User interfaces are developed using standard HTML and JavaScript. So we provide actually a lot of demos already. And on the left, you can visualize the raw signal. We have a few spellers, so virtual keyboards that you can control with your mind. The last one allows you to see the signal quality when you place the electrodes on the scalp. We have a lot of other examples. We'll touch the subject a bit later. Pipelines. So the pipeline is the steps that you take from the acquisition to the processing to the feedback. So it works a bit like that. If you have done some computer science classes, probably you are familiar with the directed acyclic graph. You find it everywhere in computer science, for instance, in dependency resolution or this kind of thing, or in the Linux kernel, which module should be loaded before another one. So a DAG is a set of nodes connected by edges where information flows in a given direction without any loop. Remember, without any loop. So we can imagine that this first node would be the acquisition. So it will get the data directly from the edge. Then it will send the data to both, to maybe, it's purely something that I'm inventing on the spot, but we can imagine that this node will do some filtering. Then it sends the data on another node, and maybe this node will be responsible to record the data on disk. And maybe another node will be able to extract features from the data. And then we have a machine learning classification engine or something. Without any loop, remember that. But earlier, we developed this concept of closed loop, which we have in a BCI. So how do we handle this concept of closed loop? With DAG, which by principle doesn't have any loop. Well, it's simple. We just use multiple DAGs at the same time, and we communicate through each node through an asynchronous process called PubSub, publish subscribe. How many of you know about the PubSub protocol? All right. So imagine you are on a Telegram group. Oh, okay. Interesting. Okay. Meanwhile, imagine you are on a Telegram group. You will subscribe. Okay. You will subscribe to a communication group, and you will send messages. And when somebody is sending a message to the group, you will receive it, of course. But all the other subscribers will also receive the same message. So basically, publish, subscribe work like that. You publish to a topic, and you receive information from the topic you've been subscribing to. So anyway, the important thing to remember is that nodes in one graph will execute in sequentially, and graphs will run in parallel, each in its own thread or process, according to the platform you're working on. All right. I don't think I have a lot of time to properly explain this, but this is the general syntax that we use to build pipelines. It's just a simple YAML. So in this example, we have 4 nodes. The first node will generate random data. The second node will add a value, arbitrary value to the whole matrix. And we will have 2 display nodes, one node to display the random data, unaltered random data, and another node which will display the modified matrix. And it's really simple, as you can see. We need 3 lines per node, one to an ID, a Python module, and a Python class with arbitrary parameters. And then we connect the nodes together. So we connect the random node to the add node, we connect the random node to the display before node, we connect the add node to the display after node. And we have another thing, which is the rate, which determines which rate we need to update the graph. Okay, let me go a little bit faster. So this is just an example node. I won't get into details, but it's just to show you that it's really easy with Python to build your own custom node. We have a full template on GitHub that you can use for that. And if you're lost, we strongly urge you to check the documentation website where you have all the interface documentation, etc. So in brain-computer interfaces, we have interfaces. And we developed timeflux.js, which is a JavaScript API that allows you to build user interfaces available from a web browser, to receive and send data streams and events, and to deliver precisely scheduled stimuli. And about stimulus presentation, it's kind of hard to have this sub-millisecond precision in a web browser, but TimeFlux make it easy, so you can just simply use the JavaScript API and everything will work perfectly. This is something that has been thoroughly tested with the photodiode on the screen, etc. And we can see, we can get this kind of shapes directly from the synchronization, which would not be possible if the synchronization has been imprecise. The orange line is a textbook P300 signal that is emitted by the brain when you are recognizing something. And of course, we train that against a machine learning algorithm, and we have very good scores. And this would not be possible if synchronization was not working. All right, let's build a brain-computer interface. So what I'll do a short 5-minute demo, and we will build this, which is a virtual keyboard that you can control with your mind. So I will play a short video, and I will comment it. So, interesting. All right, so on the left, we have the console, the terminal where everything is launched. On the right, it's a web browser. This is the EEG signal from my brain. The data is auto-scaled, so there was a lot of noise at the beginning, but we're starting to have a good signal. So this kind of spike is when I blink. So you can see that it's very sensitive. This kind of waveform is called alpha waveform, alpha, and it happens when I close my eyes or I'm in a red state. So I was just checking the data before that, and then we start the keyboard with the calibration state. So because it's machine learning, right? So we need some data, we train an algorithm on this data, and we see what if we are able to extract meaningful data from this. So we have a keyboard. We ask the subject to focus on a specific character. So now the subject is instructed to focus on the eye. And each time the eye is flashing, we get a very specific waveform that it's called the P300 waveform, P300, because this is a waveform that appears 300 milliseconds approximately after you recognize something. So why do we also have the small smiley face? Because our brains are hardwired to recognize faces. So the face detection arises about 100 milliseconds after the stimulus. So in a way, it helps us to reinforce the pattern. So right now we have two patterns we are looking for: the face detection algorithm that works in the brain 100 milliseconds, and the flashing when I recognize that the character I'm looking for is flashed. It happens 300 milliseconds later. So the calibration is nearly done. This is one character, and then, so we need to focus on the U. And the final character, we ask the subject to focus on the X. So each time a small smiley appears on the X, we detect both the face and the P300. Okay, calibration is done. We are now training a machine learning model. So it takes a bit of time here because I'm recording the screen and I'm on a slow computer, but usually in a quarter second, we can train the full model. And now we are in the real mode. So I'm focusing on the character, here, the H, and it is detected. Now we focus on the E, and it's correctly detected. So I don't have much time to go thoroughly through the end of the demo, but you can guess that I'm starting to spell hello world with my mind. So this is the application schema. Again, not much time for details, but we basically acquire the signal, we apply some filtering, we send everything to a broker. On one side, we record the data, on another, we manage the user interface, and we have the full classification pipeline where we get the data, we epoch it, we remove some data which is not useful, we train it, and then we have this prediction node which accumulates probabilities from our machine learning engine and will emit a final prediction. Regarding the final prediction, we've written a paper on that. It's called Bayesian accumulation and early stopping. You can refer to the paper if you need it. Again, TimeFlux comes with a lot of tools and plugins. I don't have time to evoke them all. One important one is, again, remember the signal, the EEG signal is very noisy. And we have this algorithm based on Riemann geometry that allows us to simplify and denoise the signal. We have CVEP, Spiller, which is basically really the state of the art in terms of brain-computer interfaces. The concepts are a little more difficult to apprehend, so I won't go into details, but everything is here. And the code is available online. And we have some papers. So a lot of different kind of EEG machine learning algorithm have been implemented. More are coming. All the code is open source and available on GitHub. We have a lot of features and improvements which are on the pipes. It will come in the next version 1 will arrive in the next few months. And one of the most important improvement is a full integrated application where you don't have anything to install. I'd just like to spend 30 seconds on sustainable open source. Because we are open source developers. So we are not paid for this. And still we have to pay the rent and we need to heat and etc. So my work is sponsored by a few companies that I'd like to give credit, companies and research institute. Another way of monetizing open source is we are developing currently an open source EEG system that is research grade, which is developed in India. And it will be available in a few months. And I think I need to reach the conclusion right now. We have a few challenges, perspective, and collaboration that we need to solve. I won't get into details. But if you need help on the topic, I invite you to visit the website, to read the documentation and tutorial, to report back on GitHub. You can join the Slack channel if you have any question, or you can even write to me directly. Again, if you are interested by this kind of project, we are looking for developers, mostly in DSP and machine learning. We are also building a new front end in Rust. So if there are the Rust developers in the room, please contact me. We need front-end developers and DevOps. And I think that's it. So thanks a lot.
Thank you so much. So that was the last talk of our event. We have a closing ceremony at 7:20 in IIT. So if you want to join us, you can please move to that room. Thank you.
Yes.
I'll need that.
The what, sir?
The mic.
Oh.